So yeah, I'm sorry that Ken didn't come, but hopefully I can do a decent job. So today my talk is going to be about server-side rendering React, but in Reason. But before that, let me introduce myself. I'm David Sancho. David Sancho doesn't really matter. I'm from Barcelona. I work at a company called Ahrefs. It's going to matter in a second. And before that, I used to work at Typeform. And aside from my current job, part of my current job is working on open source. And I maintain a few ReasonML related projects. Aside from the computer, I love triathlon, running and cycling. Swimming is not my thing, but yeah, the rest of the sports, I love them. Ahrefs. Ahrefs is the third world biggest crawler on the internet. Above us, it's Bing and Google. Our business is just, we crawl the internet non-stop for the last 10 years, and then we provide this data to SEO specialists, marketers, big companies, and they can optimize the website for their visitors, and they have like a lot of reports, a lot of like data around, and then they can optimize their website, get more visitors. I know, like all the SEO world, right? Aside from our dashboard or our tool for SEO, we are developing a search engine. So we want to compete with Google because we have the same index size as Google. So we are working for the last 3 or 4 years with search engine. It's still in beta, but yeah, it's good enough. But yeah, still a lot to polish there. So I want to explain my journey into functional programming. I'm gonna mention it a few times, but it's not really super important. But I just wanted to share it. So my journey into functional programming is when I got into React, like 8 years ago or so. I started developing kind of like a learning for functional programming, like purity or immutability were terms that I didn't before, and I needed to learn to get my job better. And I tried to get into learning more and more and more, and then that got me into Elm. Another functional programming language that compiles to JavaScript that was really, really good, but there were some things that were missing, and then after that, I got into Reason and OCaml. So before that, this talk is not going to be about JavaScript or TypeScript. I'm sorry if you came for this. It's going to be about Reason, right? Who here can somebody raise a hand who knows what Reason is? Okay, 1/3 of the people, I think, they raised the hand. So yeah, let me introduce Reason very fast because I want to explain like what I did, not kind of the technology itself. What's Reason, right? So Reason is a functional programming language. It's strongly typed, and it comes from OCaml, right? I'm from Barcelona, so you can think about Catalan and Spanish, kind of. But I don't want to get into those troubles. So what's OCaml, right? Like I mentioned, like 2 programming languages. They share 99% of the things except one, and I'm gonna explain why. But first, what's OCaml? Comes from the meta language family, like all the old people. There's not many old people here, but the standard ML, an F#, or Camel, which is like his father. They have like a whole family of programming language. It's immutable. It's performant. Some people compare it with C or C++ or Rust because it compiles to native. It's safe, so it's strongly typed. One of the biggest selling points or benefits of using OCaml is the type system. It's practical in the sense of there's functional programming languages that are like super strict, right? That you do need to do a lot of Django to get a hello world. It's practical, so you can opt out for the functional world, do a console log, and then continue with your life. So in that sense, it's very practical. And one of the greatest things about OCaml as well is it's inferred. So you don't need to declare most of the types because the compiler is smart enough to guess based on your usage which types are you using, right? So most of the times you don't annotate the types, and the compiler tells perfectly where the error happens, right? Aside from the actual technical part, it's a battle tested, so I think it's like 20 years old. It influenced a lot of programming languages, and it's very good to start a programming language with OCaml. Rust's first version was written in OCaml, for example, and influenced like all programming languages now that functional kind of like became trendy. As I said, it's very portable, so you can compile to native code, you can compile to bytecode or JavaScript, and they are working now on WebAssembly. There's good tooling because there's a lot of people who works on these languages that they really like the editor experience and so on. So yeah, the experience is very good. The compiler is fast, and there's a decent package manager. And as I said before, it's very good to write parsers, compilers, DSLs, even state machines. And as someone once said, all your programming languages, all your programs, eventually are going to become a compiler. Even though you might write front-end most of the times, you can think of your front-end gets the data from the database and compiles to whatever HTML or whatever React. So in that sense, if you develop enough for a program, you're going to create a compiler, even though you don't think of that as a compiler. And the last thing is that big companies use it. There's like, and we're proud to be one of the big companies using it, among others, right? But let's go back to reason. Is like why another programming language? Why no? Like why do we need it, right? With all the tooling it's around, it's a fair question to ask. So I'm gonna like quickly get out of the way. So. Reason was created by Jordan Walk. Jordan Walk was the author of React back in the days on Facebook, and he tried to bring OCaml semantics, meanings, concepts to the JavaScript community, which is like huge, and tries to like teach all these functional programming concepts that I learned and many people have learned and apply to the front end. It comes with React and could come with JSX, so like the transition from JavaScript or TypeScript to reason should be seamless, right? And as well, of course, it tries to be compatible with OCaml because it's the kind of like a battle-tested, perfect tooling for that. So as I said, this is a code example from reason using JSX. There are some quirks here, there are some differences, of course, but overall, I think everybody can guess that this is a counter, right? To get you a sense of what syntax differences are between OCaml and reason, this is kind of like a translated code from one example, and it looks unfamiliar to maybe most of us, but then the reason version it's way more familiar to JavaScript people. Adds like a few syntactic sugars here and there, so you can get up to speed very fast, right? Yeah, exactly. So the first question that you might have thinking is like, why not TypeScript? What's like if it's already there, right? Like it crosses all the checks, right? It's type safe as well, has JSX, it's safe, like code can be sound, right? But there's some, oh sorry, TypeScript is the king apparently. But there's some bugs on it, right? No bugs in the sense of code bugs, but the runtime is not fast enough sometimes. Not everybody wants to be performant or need to be performant. Sometimes TypeScript can lie, so you actually are using a type system, but sometimes you can fall into a trap of unsafety. Some teams might not prefer that, of course, and for example, it's like very slow to compile, which is not a big deal, but still annoying. So I heard this quote like last week, which is very good when using it properly, but it's very easy to use it wrong, right? And the big proof is that if you go to go to GitHub and you search for any and the language TypeScript, there's 11 million files that contains at least one any in the code, which is like a lot of unsafety. You know, like of course there are any that are good cases of any, there are like some avoidable. It's sometimes you need to rush and you put an any and you forget you forget about it and you ship whatever code. But around 11 million problems, there might be there, you know, there might be public, so you can like your code can crash in any form of way. Sorry. Yep. Right. So let me fast look at reason in the eyes of TypeScript for a second, and then we can end this bottle war. So TypeScript is mutable by default. So for example, you have like a type user, type billing. Those both are objects, and then you have like a function that calculates pricing, doesn't really matter. If it's paid, it's 0. If it's not paid, you calculate the discount, right? So if you run this code with price 20 and discount 50%, it should give 10. But if for some reason there's a function that gets the same user, you have no guarantees that your function, your calculate pricing, are going to behave as you expected, right? Because there's mutation, right? You can opt into immutability, saying, oh, user paid should be read-only, so the TypeScript compiler would say, no, pay it cannot mutate the user object. That's very good. But still, there are some cases where you can lie still. Like there's some, and this code doesn't look too bad. You know, if you are in a code review and you look it fast, you're like, well, that's reasonable. I don't know. That's okay, I guess. But of course, there's a bug there. I mean, there's other ways to opt out from safety that can shot you in your gun. And if you have like a big code base, those problems are super hard to fix, right? Because you trust on TypeScript, but TypeScript is not really there yet. For example, if I get the same code into Reason, same, you have a type, which is a record, and under the calculate pricing, you know for sure that user is not going to be mutated, right? You know that nobody can change what user is, nobody can change what billing is, right? So you are in a safe space to do any sort of thing that your whole program doesn't matter when you're coding that specific function. And I think when you have like this code example is silly, you know, but when you have, I don't know, 500 components, that becomes like a necessity, right? Another good thing about Reason is that it's type inferred, right? As I said before, so you don't need to annotate the types, right? The type checker is smart enough because we used user.paid is smart enough to guess which type is the correct one, right? So the compiler looks around to see which fields exist in your types and can infer perfectly. So if you would later you would try to do user.isAdmin, the type checker would say you should not do that. It doesn't exist, right? One of the other things that I'm not very fan of TypeScript is that most data structures in TypeScript code base, my code base, if I write TypeScript, are objects, right? Those objects are usually like a dynamic key, so you can have any sort of key that is a string and can contain a number of a value, which is fine. That's how JavaScript is intended to be. But most of the times you don't want an object, right? Most of the times you want maybe a map, maybe you want a dictionary, maybe you want a graph, maybe you want a tree. And the fact that TypeScript kind of like lets only, because it's JavaScript of course, but because it lets you only define your types as objects, it's a pain to work on later, right? Functional programming teaches you other data structures that you don't actually realize that you're using a hash or a map or whatever, unless you stop using TypeScript, right? One of the greatest features of TypeScript, for example, is the pattern matching or union types, right? You can have here a user that is like basic guest to pro, right? And you can have the literal guest and with the type or whatever, and a few random fields like name or company, whatever. Sorry. That's a mistake. So yeah, you can get the name, and you would use switch statement. Switch statements are not very used in JavaScript, which is like a sad truth, but it's fine, right? Like it's rare code to write those days. But here, if you add another variant, you know, another union type, the TypeScript compiler would not complain in your switch statement. So if you have this code repeated over and over from your code base, you need to find and replace or run your tests or do any sort of thing. The safe way of doing it is what's called the exhaustive word, right? So like you would have a function on the default case where you would raise, so the type checker would say, oh, this case never happened, should not happen. So all switch cases are covered, right? That's the selling point of variants or union types in Reason is that each variant contains a payload inside, and as soon as you add another variant, all the switch statements that are very used in Reason, they are exhaustive by default, right? So as soon as usually my work is like some product owner comes and said, you need to add another button, whatever, another kind of button. I add the type, and then I follow the type checker on, and because I know that it's always exhaustive and it's immutability, I only need to follow the compiler, and I know for sure it's going to work. These guarantees don't always apply to TypeScript. So my kind of like recommendation, I don't want to sell Reason at anyone. I'm not a salesman, but I prefer, and I think you would like to prefer, so if you always use strict mode, if you prefer simple data types and proper data structures, if you use read-only or immutability, or you hate a little bit the nullability problems, and you use TS-reset a lot, and maybe you like to encode your I/O, JSON, whatever with Zot to make your random objects to be type safe, and you want better language constructors, I think you would love Reason, right? That's kind of the selling point. If you want a little bit more type safety but more expressiveness, then Reason is a good choice, right? So let's finish the language wars. I'm not here to pick up a battle, and enough of the context. Let's go into the problem, right? Yeah. If you didn't fall asleep, thanks. Sorry. So let's back to problem. Let's back to reality. Stop. The bashing on TypeScript or whatever. So that was like a few years ago at Ahrefs. We had a problem. So let me first go to what was the state of at that time of Ahrefs. So 95% of code is Reason, so it's type safe. We have 20 or so front-end developers, and we have 5,000 components. We have 10 SPAs under a multi-page application, so the classic routes, and then 3 public sites that are a little bit more small, right? The problem at Ahrefs in a few years back was that most of our React applications were client-side rendering, right? We had like these gigantic applications. We used to work on a monorepo, so like we had a gigantic application that was client-side rendered. So the classic, you would like the user would join the dashboard, and you would see a spinner over and over until it loaded, and it was usable. So the problem the problem that users faced was that, of course, you would navigate from tool to tool, report from report, from, I don't know, like Site Explorer, we call it, or Keyword Explorer, and you would need to wait a lot to load the page, so users would keep like 27 tabs open to not need to reload. That was a pain point for the user experience for them. So in order to solve that, our first approach was to pre-rendering with SSG with Node, right? So you want to generate one template for each language. So you would build on the build, or on the CI, on the continuous integration system, you would build those templates, those pages, and you would push them into the backend, and backend would serve the static pages, right? So, but we quickly realized that was had a lot of problems, right? The problems were like we have 14 or so languages. So for some reason now the CI system needs to know these things. They need to know that we have like more languages. You need to change the CI when we add a new language. That was a little bit painful. And then of course we needed to purge the cache. So when you do a deploy, you need to change to one of those templates. Now the CI system needed to know how to purge the cache, which pages need to purge, for how long, many times a day. So that became like a kind of a clear mess. And aside from that, like the templates can be unsafe, right? So you could introduce a bug on our templates. We are very good fans of safety, as you might guess. So this approach was not really something that we wanted to push for the whole organization. The other approach was to server-side rendering with TXML. TXML is a library from OCaml, from Reason, that you can safely create these components from the server, right? And that was fine. We deployed one of the versions, so the backend would return these TXML components. You can think of them as React components, not really, but as React components. And the first load will be instant, right? That's the second approach. Sorry. So yeah, that's a GIF. I think I recorded 2 days ago with the slow connection. So you see the header loads instantly. Those are TXML components. and then the whole React app renders later, right? That's a good approach. That was like a nice solution for them. That's a current usage now at Ahrefs. But there was like a huge problem, right? Because those TXML components were not React components. So we started thinking, okay, so if we want to render more than the header, want to render more parts of the app, like sidebar or the subheader that we call it, we need to port our design system to TXML. And that was like, that doesn't make any sense because like the server components, they need to be aware of what data, what interactions. There's a lot of duplicity, and we had like the design system already very polished, and there were like a very nice set of components. So that was like, our second approach was, oh, we might fucked up a little bit, you know? Like that's a bad route to take. We don't want to duplicate all our components. That's not something that nobody wants ever to do. Right, so we were, so well, now what, you know? What's the next step, you know? And then somebody said, why are you overcomplicating all of this? Why not go with classic running your node close to your backend? Our backend is not camel, but why don't you put like a node server on top in front? And then does the server start rendering for you? And you forgot about all of this. So as I said before, the runtime node is not as fast, at least for us, and there are a lot of reasons for that, right? Node is single-threaded, so yeah, it can be a very expensive operation to render big trees of components. Node is a little bit bad on memory management, so because you nest all these React components, all these functions that generate objects, it became very clear that the memory spikes insane when you use Node in production. There was like a thing where, because we only use one programming language, you would need to go to the DevOps and say, no, you need to deploy this thing, but it's completely different from what you had before. There's different rules, there's different things. So they were like not very good fans of Node whatsoever. So that was another problem. Of course, there's like type safety. If we wanted to get type safe, we would need to either go to TypeScript or either go to Reason and compile to Node. That's not something that we really want. I think we lose type safety on that area, and I think templates or server-side rendering is a very weak part of your application to have safety problems, right? The other thing, and I think that's the biggest one, is that you might need to duplicate most of your backend logic, right? You would need to authenticate a Node service with the same rules as the OCaml one. So we need to duplicate all of this work, right? And that was something that, again, nobody wanted to do, right? So, and of course, if you want to, for example, to move one server request to a client request, you would need to do a lot of work because you would need to swap code from one language to another. You would need to have the same constructors, same HTTP client, same endpoints, same types. So that was like a no-go as well, right? So I started thinking, but what's server? What's React on a server, right? What React does on the server, and if it's even possible to re-implement it, right? I realized that it's only React DOM server, so I started thinking, wait, on the server, use state does nothing, right? Use state doesn't do absolutely anything in the server. Okay, that's good. Use effect on fire, right? Like all your use effects do nothing on the server, right? Use memo only returns the value, right? Doesn't do any memoization whatsoever on the server. Use callback doesn't do anything because you shouldn't call your functions from the use callback on the server. How hydration will work though? That was still a thing. So virtual diffing shouldn't happen on the server because there's only a single pass. And then I started thinking a little bit more, and then suspense, and then how we would implement suspense, and what would be the single pass, you know? And then I realized it's only React DOM server, right? So let me explain what this means. So the actual server-side logic for rendering React, you have like JSX, you have like a set of components that you want to translate to HTML, right? That's the whole thing. You want to do it in single pass, so you traverse the tree and return it into HTML, right? That's the actual output that the response should receive is exactly this, and the browser should render instantly because it's HTML, right? That's made for that. So if we get into the what's React, we can define React as element that has a union type, right? It can be empty, it can be text, it can be a list, it can be a fragment, it can be an HTML element like a div, h1, span, h2, whatever. It can be a component, so a function that returns an element. It can be provided, a consumer, or a suspense, right? This type is recursive, as you can see, because of course a component can render an element, or a fragment can contain an element, or a list can contain a list of elements. So it needs to be recursive, right? This is how React works. They have, of course, different implementation, but that's how React works. How server rendering works is as simple. This is a simplification, but the idea is that you have like a render function. You receive an element, like the top element on your app, and on each case, you just need to return a string, right? That's of course, that's not the implementation real on my library, but the idea is exactly the same. So you go for one case, you recursively call a function, and at the end you have like a gigantic string, right? And then when I kind of like solve all of this, I created server reason React, which is the thing that I'm presenting to all of you. So the idea is that I re-implemented 3 APIs, which is the render to string, render to markup string, and render to stream. Those 3 are the ones that are as well provided by React. There's now server components and whatnot. We're going to talk about a little later. But the actual first work was to get these 3 working in reason, right? And I was very, very happy. With that implemented in mind, it enabled to have one React component or many, and then you can compile to JavaScript using Melange or with OCaml to native, right? So you have one version of the component that can run on the browser and can run on the server. So now we don't have duplication of components. Now our design system can run on the native side, and we don't need to re-implement logic, re-implement authentication, re-implement anything. Just use the server reason React, right? Every time that I explain these to people, like, oh, we render React on the server, first question is like, but how much is the performance? How fast it is, you know? And at the beginning, I didn't build it because it was needed to be very performant or performant than others or whatever. It needed to be performant enough. But people keep asking, so I think it's kind of like juicy to know how fast it is when you run native code compared to Node or compared to other engines. So I did it kind of a small benchmark, same code. I compile it to JavaScript and then I run it in Node. I compile it to JavaScript and I run it with Boon, and then my implementation. And I run a small benchmark, and it destroys the competition, right? It's like absurd, you know? Even though thanks, but like I didn't make it fast, you know, like the tools were there. I just plug and play the code. But the idea is that even though Node is very well maintained, very optimized for performance, V8, the C++ engine that is running below, it's handled by a team of 30 people. And of course, like there are new players like Bun. There's the Jared guy who keeps matching Node with benchmarks, and it's like there's a lot of performance. You can see that native code it's absurdly fast, you know. But with one caveat that all micro benchmarks are false. Like you should not believe what pops up on your Twitter, pops up in the readmes of your GitHub, where even my benchmark is good enough, but it's not a real case scenario, right? My benchmarks run on the CI of GitHub or whatnot. I haven't run them in production with real usage, with other services running, with I don't know, with multi-core going. So there's this always like when you, depending on how you create the benchmarks, you can play around with the numbers. So I wanted to prove that it was fast enough, and I didn't profile it. I didn't went very, very far into performance. I might eventually go into those problems, but since it's not a problem for now, I would not pursue the battle of the micro benchmarks thingy. Just to prove you exactly that, if you go to the BAN website, it explains, it gives you the kind of like we are faster than anybody else because blah blah blah, which is it's true. Like their benchmarks does exactly what the results are. I'm not saying that that's false. It's just like I mean that the micro benchmarks are very easy to tweak, right? Depending on how you render, how many components do you render, what your components does, and what not. You can see the graph that the bunches are out. The reason because of that is because performance. There's like hundreds of variables that imply performance, right? You can always tick those variables in your favor or not, depending on what you want to present on your website, right? So yeah, the benefits for us to use server using React, as I said, the performance is much better. That was cool. Allows to further exploration with the OCaml multicore, and I'm going to explain a little bit what OCaml multicore is. So OCaml has been working for 10 years on multicore, which it means that you can run code safely on different cores of your language. For example, in Node, it's not possible. There are some ways to work around with using workers, but having a language primitive that runs on multicore, it can allow us to parallelize operations very, very fast, right? For example, our developer environment, it's not on our local machines. It's on a shared server with 256 cores, I believe. So I could run the server on each core. I don't know, like all the templates on one of each core, and the performance would be 2,000 faster, you know, like absurd number. So multicore as well enables parallelism. So you could fork, so the same way as you can use with promises, but there are different language constructs that you can fork processes and join them much more easy, right? The other thing that are working on in OCaml, and I think everybody's looking forward, is effects. Effects is the way to resumability, how to resume, I don't know the word. So it's a way to trigger an exception and catch it somewhere else. It's exactly how the suspense model works, where you have like a tree of components. There's one component that can raise a promise, and you can have a suspense here, and it catches. So it's the same concepts, but on the language level. So we, at some point, when this lands on OCaml, on reason we only need to use it, right? It's going to be available for us. So the status of all of this is still in beta. Like I'm working on it constantly, and still is not polished for more people that are not invested in the ecosystem to use it. As I said, it's deployed to a few parts of Ahrefs, for example, the dashboard and a small public page called WorkOn. And we have plans to refactor more apps in our code base, and we are working on that. But after kind of like the one disclaimer is that you might not want to use it, right? Though it's totally fair. It's a new language, it's a new package manager, it's a new runtime, right? Like all the knowledge you might need to throw it away. Not throw it away, but of course, because like knowledge across the server or the backend, you can apply it to any sort of platform. And the learning curve can be big. So I got into kind of very easy functional programming kind of way, but it might not be your case, so you might struggle. And not everybody needs this, you know. For Ahrefs made a lot of sense. It was a great project, was a great success, but it might not be your case. And as I said, there are some parts that are very experimental. Some conclusions, learnings. I'm running out of time, so I'm going to be a little bit fast now. So go with an ambitious approach. You know, like this field is amazing. There are so many things to learn. If you choose the ambitious approach, you're going to have crazy good fun, as we did. The other learning is the React paradigm is simple but extremely powerful. So I only needed to re-implement something that was already meant to be on OCaml. The other learning that, of course, I realized during all of these years that all programs will become compilers eventually. The other thing is that as a front-end developer, back-end development cannot be split. You know, we cannot, at least from our team, we cannot have like knowledge split it from two teams. We need to collaborate, and I think server rendering is one of those. And OCaml and Reason are fantastic. And I think the last one is that re-implementing is a great way to become an expert. I accidentally become an expert on how React does the rendering. So I could not explain this talk or understand all the concepts that we have been learning during these 2 days if it wasn't because I get deep into re-implementing the thing, and I enjoyed a lot. So thanks for listening. If you want to check out more, you can check out the links or follow me on Twitter or talk to me afterwards. That'll be a pleasure. So thank you.